Hello everyone, welcome to my channel. So today I'm going to explain what is reactive programming, and to do that I'm going to take a very simple real world example to compare the blocking versus non-blocking flow. Later I'll correlate this to our actual application flow where I'll compare traditional REST API design versus reactive programming and what are the benefits of using reactive programming. So let's begin. Once there was a man who wanted to start a restaurant business. So he bought a land, he built the restaurant, and he hired three waiters and a cook. Inauguration day came, celebration began, and man was very happy. And he was ready to welcome the guests. So the first group came, waiter number one went to the table, took the order. The next group came, waiter number two went to the table and took the order. Meanwhile, as you can see, waiter number one went to the kitchen so that he can give the order for the food preparation. Now the next group came, waiter number 3 went to the table to take the order. Meanwhile, as you can see, even the waiter number 2 went to the kitchen to give the order. Later, waiter number 3 joined them in the kitchen so that he can also give the order for the food preparation. Now the restaurant owner was very happy. It was the first day of the restaurant and there were a lot of customers that were coming in. Even his staff was completely busy. He thought that this restaurant is going to be a great success. Even the customers were happy as it was a fancy restaurant with great interior and ambience. But later, one more group came. So restaurant owner told them to have a seat. They waited for some time, but after some time, one of them got very angry. She called the restaurant owner and told that there is no waiter to take our order. So restaurant owner now got afraid. He thought that all my waiters are blocked in the kitchen to take the order. So might be I need to hire a few more waiters. So this, my friend, is a blocking and synchronous flow. As you can see, all the waiters are blocked in the kitchen and they are waiting for the food to be prepared. And none of them is available to take the order from the new customers. And why synchronous? Because everything is happening one after the another. Nothing is happening in parallel. Okay, now restaurant owner went home. He called his friend and said, I have opened a restaurant. It is a great success. But I think I need to hire more waiters because at certain point of time, all my waiters are busy in the kitchen taking the order. So his friend said, hold on, don't do that. I'll give you an idea and you can try to implement that. So next day, restaurant owner tried to implement the idea that was given by his friend and he informed about this idea to all his waiters. So the first group came, waiter number 1 went to take the order. The next group came, waiter number 2 went to take the order. And as usual, waiter number 1 went to the kitchen so that he can give the order to the cook for food preparation. But this time, he tried to implement the new idea as instructed by the restaurant owner. So restaurant owner told the waiters that whenever you go to the kitchen, don't wait there. You give the order and you come back to the restaurant and see if there are any new customers from whom you can take the order. And whenever the food is ready, cook will call you. So the waiter number 1 exactly did that. So when a new group came, as he was free, he went to the table to take the order. And waiter number 2, who already took the order from the customers, went to the kitchen and gave the order to the cook. Now the next group came, as waiter number 3 was free, he went to the table to take the order and then he went to the kitchen to give the order for food preparation. And at certain point of time, all three waiters were free as there were no new customers that were coming in. Now the cook said that the food is ready for so and so order. For example, say order number 1, and then a random waiter, say waiter number 2, went to the kitchen to pick up the food and served it to the customer. So this flow continued. The food was prepared. Cook called the waiters to pick up the orders, and waiters went and served the order to the customers. But in this, you can see there was a new group that came in. And since waiter number 2 was free, he went to that table to take the order. So this, my friend, is a non-blocking and asynchronous flow. As you can see, none of the waiters were blocked in the kitchen and they were not waiting for the food to be prepared. Instead, they went back to the table, and whenever the new customers were there, they took the new order. And whenever the food was ready, the cook called them and they went one by one, picked up the food and served it to the customer. So this is non-blocking and asynchronous because everything is happening in parallel, right? Nothing is happening one after the another. So great. Now restaurant owner was happy and the celebration continued. So let's look at the traditional REST API design. So for this, just remember the first flow of our restaurant example and you will be perfectly able to understand this entire flow. So to begin with, as you can see, there are multiple clients like a smart home, a mobile user, a laptop user, and also a connected car. They are making the request to our app, okay? And our app is having an embedded Tomcat. Now let's just take an example of one particular request. Say the request that is coming from a smart home, okay? So it reaches our app. Now what Tomcat is going to do is it will assign the thread to that particular request. So it will assign one particular thread to that request, and that thread will be responsible to execute that request end to end. Okay. Now let's just assume that this request is responsible to get the user details. Okay. And this request has now reached our repository layer, and thread has made a query to the database to get the response which has the user details. Okay. Now assume there are multiple clients making multiple requests. All are going to our app, and what Tomcat is doing for each request, it is assigning one particular thread which is responsible for executing that request end to end, right? And all of the threads are now at the repository layer and they are waiting for getting the response from the database. Okay. And if for any reason the database is responding slow, you can imagine that all the threads are now blocked, okay, as they are waiting for getting the response from the database, and none of the thread can now serve any new request, right? So if you remember, even in our restaurant example for the first flow, the waiters were waiting in the kitchen to get the food and they were waiting for the food preparation, and none of them were available to take the order from the new customer, right? Similarly over here, all the threads are blocked and they are waiting for getting the response from the database and they are not able to serve any new requests. So this is a blocking flow. Let's look at what are the disadvantages. So the disadvantages are a thread per request model. So one particular thread is responsible for one particular request. So for every request, there is one particular thread responsible. Okay. So which means if all the threads are utilized from the thread pool, there is no thread available to take the new request, and there are chances that the application will not be able to respond, right? As you might be aware, whenever a thread is created, a stack size is assigned to that particular thread. So for each thread, there is a stack size, and which is around 1 MB. So more the number of thread, more the memory consumption. Okay. And next one is blocking and synchronous. Blocking, we have already seen that all the threads are blocked and they are waiting to get the response from the database, right? And synchronous because the thread, until and unless it completes the entire execution from end to end, it can't go and serve the next request, right? So it is one after the another, it is not in parallel. So that is why it is blocking and synchronous. Next is limit on the number of concurrent user. As I already explained, if suppose all the threads from the thread pools are busy now, none of the thread are available to take the new request. That will limit the number of users, right? And no back pressure support. So back pressure we'll be looking in detail when we will do the coding and when we'll see our reactive programming part. Okay, so for now just understand that in back pressure what happens is if producer is producing the messages very rapidly and consumer is not able to consume those message at same speed, so consumer can tell the publisher or the producer that I can just consume 5 messages at a time. Okay, so that is back pressure. Now let's look at what is reactive programming. So for this, remember the second flow of our restaurant example. Okay, So over here, same thing, there are multiple clients that are making requests to our app. Okay, but there is something different that will happen now. So when a request comes, the thread is assigned to that particular request, but that thread is only responsible to put that request as an event in an event queue. Okay, so there is an event queue over here. So that thread is only responsible for putting the event in that event queue. And yeah, just a reminder over here, the server that I'm talking about over here is a netty. So by default, whenever we select a Spring Web Flux as a dependency in our Spring Boot application, we'll get netty as the server. Okay, so netty is the embedded server over here. So as I said that when the request comes, thread is assigned to that particular request, and that thread is only responsible for putting that request as an event in event queue. Okay, so in the next step, what will happen, there is an event loop which is continuously running. And what does that event loop do? The event loop will take the event from top of this queue. Okay, and it will pass on to the next level. So what is the next level over here? The next level over here is getting the user details from the database. Okay, at the same time, the thread one which has added the event is not going to wait for the response. It will immediately go back and serve the next request. So for example, the first request was from smart home. It can immediately go back and take the next request, say from a mobile client or a laptop user. Okay, so it is not at all blocked, it is continuously moving. Okay, and over here for the event loop, whenever the data is ready from the database, okay, that response will also be added to this event queue. Okay, and whenever the event comes at the top, the event loop is going to take that event. Okay, and it is going to give that particular response to a thread, and it can be any thread, it is not necessarily the same thread which gave the request. So it can give the response to any thread, and that thread will return the response back to the client. Okay, so as you can see, this flow is a totally non-blocking flow, none of the threads are blocked over here. Okay, so let's look at what are the advantages. So the first advantage is it is non-blocking and asynchronous. As we already saw over here, it is the thread over here is not blocked, right? If you remember, even our second flow of our restaurant example, none of the waiters were blocked, right? They used to just give the order to the cook and go back and take the new orders. And whenever the food was ready, cook used to call the waiter, and the waiter used to serve the food, right? Similarly over here, threads are not at all waiting, they're continuously moving. So that is non-blocking. And asynchronous because everything is happening in parallel. Okay, all the requests and all the flow, entire flow is happening in parallel over here, as opposite to the traditional REST API design that we saw, right? Next is it is events and message driven. As you have already seen, everything is event over here. A request is also event, a response is also event, and even if there are any exceptions, those are also events over here. So this is a totally event and message driven architecture. Then back pressure, as I already mentioned in previous slide, we are also going to look in detail when we see the publisher subscriber event flow in our next slide. But for now, it is very simple that if the producer is producing the message at rapid speed at which consumer can't consume it, then consumer can signal the producer saying that I can just consume 5 messages at a time. Next is a functional style. So whoever has worked on Java, it will be aware of what exactly the functional style is. So to give a very basic example, consider that we have an list, okay, and that list is having say 10 different integers, and I want to convert that list to a corresponding list which has square of those numbers. Okay, so using functional style, what I can do is I can apply stream on that list, okay, and then use map operation. And in that map operation, I just need to pass a function. Okay, that function is going to take a input. For example, over here it will take input as a number, and it will return the squared number as the output. Okay, so I just need to provide a function to that map operation which is going to convert the list which is just having integers add to a list which will have a square of those integers, right? So that is why it is called a functional style programming, and we are going to see in detail when we write the code for the same. Okay, So the last one and very important point over here is we need to make sure that our entire flow should be reactive to reap the benefit of reactive programming. What it means is, so there are different layers that are going to be in this entire flow, right? There is one client layer, then there is one app layer which is having netty as the server, then even our application code, then our database code, right? So all of these different components should be reactive. If any of these components, say for example database is a non-reactive database, then we will not be able to have a complete benefit, right? Because other part of our application like our client and our server, even our application code, everything is reactive. But since database is not reactive, there will be certain blocking that will happen. Okay, so to have the benefit, all the components in our flow should be reactive. So let's see what is reactive stream specification. Reactive stream specification provides a standard for asynchronous stream processing with non-blocking back pressure. We have already seen what is asynchronous and what is non-blocking. So for back pressure is a mechanism to control the speed of message consumption. So what it means is, if there is an producer who is rapidly generating the messages but consumer can't consume the messages at the speed of which the producer is producing the message, then consumer can signal the producer saying that okay, I can consume only this many messages at a time. So that is what a back pressure is, and we'll see how we can implement that. So below are the contract interfaces that needs to be implemented by a reactive library. So suppose if you're writing your own reactive library, you need to make sure that you implement the below four interfaces. For example, project reactor, which is a reactive library, implements all the interfaces that are mentioned below. So let's see what are these interfaces. We'll quickly look at what these interfaces are. And when I explain you the publisher subscriber event flow, you will exactly know how it works. So first is publisher. So publisher is basically a data source. It can be a database, it can be a web service which keeps on generating the data. So this publisher interface has a method called as subscribe, and it accepts the argument as subscriber. So whoever wants to subscribe to this publisher needs to call this method. So next interface is subscriber, and subscriber interface has the four methods. First is on subscribe method. So when a subscriber calls a subscribe method of a publisher, publisher in return will call this on subscribe method and it will provide the subscription. Next is the on next method. So publisher will call this on next method of the subscriber to basically send the data. After that, there is an on error method. So publisher can call this on error method of subscriber if there is any error that has happened, and it can signal the subscriber regarding that. And finally, there is an on complete method. If it has successfully completed sending all the data, then publisher will call this on complete method on the subscriber. Now let's look at the next interface, which is subscription. Now when subscriber calls the publisher's subscribe method, as you have seen in written, publisher will call the on subscribe method and send the subscription to the subscriber. So using this subscription, now the data flow will begin and subscriber can request or signal the publisher that it is ready to consume the data. So for that it will use the request method of the subscription, and as you can see there is an parameter or argument for the request method. Using this it can implement the back pressure. So it can say okay, I can only consume 5 messages at a time. So this is how back pressure will be implemented. And then there is a cancel method. If by any chance subscriber wants to cancel the subscription, it can use this method. The last interface is the processor interface, which basically extends both subscriber and publisher. Now let's look at the publisher subscriber event flow to understand how the flow happens and how these methods are called. So first there is a publisher and subscriber. So as that step 1, subscriber will subscribe to publisher. So it will call this subscribe method of the publisher. After that, publisher will call the on subscribe method of subscriber and it will send the subscription. So once the subscriber has received the subscription from publisher, it is now ready to request the data. Okay, so on this subscription, as you know, there is a request method. So using this request method, it will signal the publisher that it is ready to consume the data, and in the argument it can provide the number of message it can consume at a time. So it will call the request method of the subscription, and then once the signal is received by publisher will start sending the data, and for that it will call the on next method of the subscriber, and it will keep on calling the on next method until it has completed sending all the data. So whatever number of messages are there, that many times it will call the on next method, and after that, finally, once it has completed sending all the data, it will call the on complete method of the subscriber. And by this way it completes the entire flow. But there is also one on error method. So in case if there is any error that is happening, then publisher can signal the subscriber using this on error method. So first is from subscriber a subscribe method that is being called on publisher, and then publisher sends the subscription. Then on that subscription, subscriber can call the request method. After the signal is sent to publisher, publisher will call on next method and start sending the data to subscriber until all the data has been sent. The on next method will be called, and finally, once the data is completely sent, all the messages are sent, it will call the on complete method. So this is the entire flow for publisher and subscriber. Thank you. So thank you for watching my channel, guys. Kindly subscribe to my channel and feel free to like, comment and share.